Kia ora, Year 11 and 12. This is some more AS revision for you from the Winter 2017 paper, and I should have said on there that it's the first paper for that season, so it's paper 1-1. I'm going to do questions 1 and 2, so as usual, A-level guys, if you're watching, this is going to be a little bit slower than we've usually been doing it, so that everyone can follow along. So here's the first question, and it's kind of a classic calculus question. We're given a curve. I don't know why that's there. Let's just move that. Right, a curve has got the following equation. Find the equation of the tangent to the curve at the point 4, 0. So here are the steps that we're going to do. First of all, we're going to find the first derivative, the gradient function, dy by dx, or f dash of x. And then we have to find the equation of the tangent to the curve at this point. So then we're going to sub in the value of x that we want, which is f dash of 4, and that's going to give me my gradient at that point. Next, we're going to use one of two equations to get the equation of the tangent. So we're either going to use y equals mx plus c, or we're going to use y minus y1 equals m times x minus x1. So they're both good. Those of you who've got me this year will know that I am a convert now to doing it this way. That's all for that question. But I also want you to think about if that didn't say tangent and that said normal, what would we change and how we answered it. Okay, so let's pause the video now and do that question if you haven't already done it, and then I'm going to work through it with these steps. Right, so the first step is to differentiate and see what we get. It's already got fractional powers. I don't need to clean it up at all. We can just get going. So dy by dx is equal to 2 times 3 over 2x to the 1/2 minus 3 minus 4 over 2x to the negative half, and that doesn't have any derivative. So cleaning that up gives me 3x to the negative 1/2 minus 3 minus 2x to the negative 1/2. Ignore that, that was a little message from a year 9. Thank you, Jack. Right, this is wrong. This should say to the power of 1/2, right? So always check what you've done. Let's just quickly have a wee look here. This was x to the power of 3 over 2, so I've got x to the power of 1/2 down here. This was x, so I've got a constant, and this should now be x to the negative 1/2 with some coefficient. So that's looking good. We're going to write that like this, 3 root x minus 3 minus 2 over root x. And now what we have to do to find the equation of the tangent is to evaluate it at the x value of 4. So dy by dx at x equals 4 is equal to 3 times 2 minus 3 minus 2 over the square root of 4. So that's 6 minus 3 minus 2 over 2, which is 1. That gives me 2. So m is equal to 2. The equation of the tangent will be y equals mx plus c, and we know that 4, 0 is on the line. That means that I can find c as follows. So 0 is equal to 2 times 4 plus c. So c is equal to negative 8. So the equation of the tangent is y equals 2x minus 8. And you, as I said, you could do that the other way. Y minus y1 equals m into x minus x1. And your point, as above, is 4, 0. So you'd go y equals 2 times x minus 4. Now, the Cambridge markers actually gave that 4 marks. I'd much rather see it written out like that. Now, if we wanted to find the equation of the normal, all we would change in there is that we know that tangents and normals are perpendicular to each other. So instead of using m of 2, we would use m for the normal is equal to negative 1/2, and then we'd go from there into here. Right, so same idea, but with a different gradient. Right, let's look at the next question. Where is it? Here we go. Right, a function is defined by this. So we've got a cubic. Y is equal to x cubed minus x squared minus 8x plus 5. And we're told that it's defined only for x up to a value a, and that f is an increasing function. So when we say increasing function here, we mean that for the whole of the function, the gradient is positive. So let's look at what this function looks like without even drawing a set of axes. It's a positive cubic. So positive cubics usually look like this, up, down, up. What this question is asking is, what is this value of A that will make this graph have a positive gradient everywhere? So what we're trying to do is we're trying to get rid of all of, oh, I got rid of the whole line. Let's try that again. I just want the bit of the function where the gradient is positive, right? So I just want that bit because it says for x less than A. If I were asked instead to find the value where it's increasing such that x is greater than A, then I'd be looking for all of that bit. But they didn't ask me that, so we'll get rid of that bit. We're just trying to find the turnaround point on that cubic. Now, you don't have to do all of that, but I think it really helps you get an understanding of the question. So what do I have to do to figure out when something's an increasing function? Well, increasing function means the gradient must be positive, right? Right, so increasing function means f dash of x, and you can say strictly greater than 0 or weakly greater than 0. No one ever seems to get too fussy with that, or I don't think they do. F dash of x is equal to 3x squared minus 2x minus 8, and we need that to be positive. So now we're going to solve a quadratic, and we're going to do that by factorizing. It's one that we can do by inspection, I think, because this is a prime number. So this combo falls out pretty easily. I've got 3x times x here. I want to have minus 8 here. So just looking at it, let's try 4 and 2. Of course you're watching this going, yes, well she knows that because she's done it beforehand. I think this is one that you can all get pretty easily. So that gives me minus 6x plus 4x, which is going to match up here. And I'm looking for where this is positive. So if we think about graphing this gradient function, what I've got is a parabola that looks something like this, right? So where's it positive? Well, it's positive for here and here. So we want x less than negative 4/3 or x is greater than 2. But this is where we need to think about what the question was looking for. It's asking me for the largest possible value of the constant a so that the function is increasing. So what this has done here is it's telling me that when x is greater than 2, my function's increasing, but I'm not interested in that bit. So the value of a, for which the whole function will be positive, is this bit here. So a is equal to negative 4/3. Alright, that's all for now. AS people, if you want to give me some feedback about whether this is too fast, too slow, or about right, that would be really useful. A-level people, I'm sure it's a little bit too slow, so just don't watch if you don't need to watch. Let me know what kind of questions you want me to focus on next for these AS ones. Thanks for watching.